Okay, you guys are welcome to sit down if you want, or you can stand. It's up to you guys. Tammy, are you ready with the recording? Okay, whenever you're ready, yeah.
Hi, my name is Ria. I'm 15 years old. And just a few days ago, I was watching one of my all-time favorite movies, Hunger Games. And I found the concept so interesting about how the capital was controlling the districts and their resources, which led to a lack of resources and an energy crisis in the districts themselves. Unfortunately, we're on the same trajectory as the districts. In fact, it's estimated that the global energy expenditure would be 777 quintillion joules by the year 2040. And right now, we are on our process from non-renewable energy to renewable energy. But the process is just not fast enough, which means that we will run out and deplete our resources, which means we have no we have no ways to generate electricity. And this isn't just a problem for the future, but a problem for right now. In fact, 759 million people right now don't have electricity. So introducing Power Threads, a textile that can generate energy. So it eliminates your need for an external energy source. So how does this work? Essentially, our solution has three components: energy harvesting, storing, and transferring it to our electronic devices. Our first component is energy harvesting. It uses a material called PVDF, which is piezoelectric. Essentially, if you apply any pressure or mechanical force, it would create energy by displacing the positive and negative electrons. And this works. The material itself is not the only important thing, but also how it's made. So we're using a structure called core sheeting. So the core is arranged in one direction while the yarn is arranged in a different one. And basically this creates a rope type material where it's sustainable to environmental pressures. So imagine you're going on a run, and every single time you walk, there's energy being made that you can use for your phone. And why PVDF? PVDF is 11% more efficient than any other electrode in this type of environment that we're living in. In fact, researchers ran a study, and they wet a PVDF material and put it on the shoulder, and when the person was walking, 8 volts of energy was created every single time the person stepped. And PVDF is not only good for generating energy itself, but also for textiles, because it's lightweight, it is flexible, and it has storage, and it's strong, which is exactly what we need. Now coming to energy storage. Essentially, the status quo for this right now is using capacitors, but it's not efficient enough, and it's just not what we're looking for our textile. So we're using super capacitors. It's like putting tiny batteries on top of our fabric itself. Right now, researchers are looking into graphene. It's basically very conductive and has a large surface area, which means it can store a lot of energy and quickly release it too. And it creates like 50-meter long fibers that can hold 300 farad of energy per cubic centimeter. But the issue is these fibers are really, really long, so we have to use a new type of method to shorten these fibers themselves, which is laser printing. Essentially, you apply a waterproof coating as well as graphene oxide coating, which on the material itself, and then that creates a thin film layer on top of the material, and then you apply a 6-volt laser on top of this to reduce the fibers themselves. That creates a layer of electrodes on top of the material that can store this energy. There's a bunch of tests that's also been done to check the stretchability and the washability of this test itself, and it actually outperformed what the researchers thought it would. And lastly, how do we actually get this energy to be used by the consumers themselves? How do we transfer it to electricity? And so basically there's a control module in either the pocket or compartment of the clothing itself, and if you put your phone into your pocket, it will charge right up by basically controlling and making sure that the voltages and the resistance rate is exactly what you need for transferring it from supercapacitors to your electrical device. And that's all the technical side, but what about our business? So we're planning on using the approach similar to Tesla's master plan. So we're approaching it because it's a really expensive process, we're putting it into a premium market and we're hoping to get demand and cash flow from this, which we will put back into R&D to reduce our pricing and manufacturing price, so we can reach a larger audience and impact millions. Our reliance on fossil fuels today is detrimental to the environment. In fact, just like Katniss Everdeen fought for her oppressed citizens in her dystopian society, we hope to fight against the environmental degradation that is caused by fossil fuels themselves. This is done by using our alternative to create energy for day-to-day use. This is Power Threads, a textile that can store your energy, harvest it, and transfer it to your devices. Thank you, and let's work together to ensure that the odds are forever in our favor.
I have a question. You mentioned like super capacitor and that's what I was like, okay.
No, that's it.
Can you talk a little bit about the safety here? Because like
Yes, definitely. So basically, through the structure that we're using, so core shielding in themselves, as well as the laser, it's safe, and it's safe for not only like short circuits, because obviously that's a big thing, but because of the short, like the core shielding, like the structure, you can put it underwater, and there's no short circuits. The radiation does not impact the material itself, as well as humidity and the temperatures as well. It has very high endurance for that.
What are that's a really important point that I also wanted to raise. But what are the costs of building one of doing this?
Definitely. So our approximate price right now is from 50 to 100 per like item that is made, which is really high, which is why we want to like partner with high-end brands to meet this demand, because obviously with the brand we're associated with, the value is also there. And eventually, by taking this cash flow and putting it back into the company itself, we want to decrease costs so everyone can buy this style.
Yeah. Two questions. So one, follow up to the safety. Have you thought about the insulating technology within the fabric for like static discharge, which happens a lot in dry climates in the winter? The other question is, well, it's not a question, it's an advice. I think you should target high-end sportswear brands, because I jog 15K with my phone, and sometimes I run out of battery, and then I'm in the middle of nowhere with no music. So I think that's a good market.
Yeah. So for the insulating thing, because of the way the material is made, it is safe, and it does work for very dry and very cold climates themselves. And going back to the tests themselves, these tests also said that the weather does not really impact the way the material works.
I think on the similar note, like one of the things which I was curious to see is how this impacts instead of clothing, which is on whole screen. So bed sheets, sofa,
Yes,
these are like they could benefit a lot from that versus like less risk of short circuit.
Yeah, so we're planning on introducing it to more like high-end brands, so like Gucci or things like that, so it does reach the high-end market. And then as you suggested, we are planning on going into the sportswear, because that is where you're doing the most physical activity and you can generate the most energy itself. And then we're planning on joining the daily wear market, which is like 48% of the apparel industry.
Yeah, and another market I would advise is the labor market, because in some countries, I used to live in Finland and Estonia, during the winter, the requirement by law is to have a light on yourself, because it's too dark for too long. So this would be a way to like not have to worry about battery replacement, like having a light to wear, breaking the light, like if you incorporate the lighting within the clothing, and then you have the t-shirt like the material to power it. Even though it's expensive, it's something that's built through either unions or the corporations provide that.
Thank you.
Thank you.
You-
Yeah.